Okay, so in this video, I'm going to take you through 14.44c just to show you by calculation how it works if you have lines that don't meet at one point, so we have a different example to go on. So in this case, we have line G, x is the point 2, 1, plus the parameter t times the direction vector 1, negative 1. And then we have line H, which includes the point negative 3, 5, plus u times negative 2, 2. And we should notice here that our direction vectors are parallel in this case, because if I multiply this direction vector by negative 2, I get this one. Which gives me negative 2, 2, which is equal to my blue direction vector. So I have the first direction vector times a scalar is equal to my other direction vector. So here I know that these lines are either parallel or identical. And to distinguish between these two cases, we have parallel lines like this, and these lines have no points in common. And identical lines, of course, are exactly the same line, so they have all points in common. So we need to decide whether the lines have no points in common or all points in common. And we can simply, if we just show that they have one point in common, that's enough to show not this case and this case. If we can't show that they have one point in common, then we know we have this case and not this case. So, this is still a question mark. Let's see. Well, we know already that G has this point, 2, 1. And so, I'm going to ask the question, does this point lie on H? If it does lie on H, then we know that the two lines are identical. If it doesn't lie on H, we know that the two lines are parallel. I could equally well do this by selecting this point from H and seeing if that lies on G. It really doesn't matter which way around you do it. So, as I said in the previous video, this capital X should be interpreted as the coordinates x, y. So, I can say 2, 1. We're seeing if that's equal to negative 3, 5 plus u times negative 2, 2. And putting these together like I did in the previous video is minus 3 minus 2u, 5 plus 2u. And the question we're really asking here is there a u that works in both of these cases? So taking the top line, I get equation 1. I get 2 from this side is equal to negative 3 minus 2u. And our second equation, 1 is equal to 5 plus 2u. So all I need to do here is add the two equations together, and then my u will fall away. So if I take equation 1 plus equation 2, then on this side I have 2 plus 1, which is 3. And on this side I have negative 3 plus 5, which is equal to 2. Minus 2u plus 2u gives me no u. And so I end up with 3 is equal to 2, which is impossible. Therefore, this point does not lie on H. That must mean that they can't be identical, they must be parallel. Because if they were identical, the lines would share all of their points, and so this point would definitely lie on H. The only other option that we have is the two parallel lines that have no points in common. Hopefully that's cleared that up for you. So next up we have question 14.45, and I'm going to do the question part F. So, oh no, not F, sorry, D. There we go. Okay, so in D we have two lines. We have again G, which goes through point 7, 0 and has direction vector 3, 2. And then we have H, which is the line segment CD, where C is -2, -3, and D is equal to 22, 7. And we need to see whether these two cross. So here with H, I'm going to create a direction vector and an equation, a vector equation for this line. So H is x is equal to a point on H, which is -2, -3, plus a parameter u times a direction vector, and I'm going to take the direction vector c to d, which is of course d minus c, which is 22, 7 minus -2, -3, which is 24, 10. And in this case, because H is just this line segment, I have parameters for u. If I start at C, I can travel as far along this line until I get to D. And this direction vector is what would get me from C to D. So in this case, u has to be between 0 and 1. When u is 0, I'm at point C. When u is 1, I'm at point D. And so then, I can go between those 2 points, but no further. So the first thing I should ask myself is, are the direction vectors parallel? And I can see that I would have to times 3 by 8 to get 24, but I'd only need to times 2 by 5 to get to 10. So no. There is no scalar r such that A is equal to r times B. This must mean the lines cross. And to show where the lines cross, I just need to find the coordinates x and y of the point of intersection. So the point of intersection is when xg is equal to xh and yg is equal to yh. So I can say when 7 plus 3t, multiplying this out, and 2t is equal to the coordinates for h, which is the x coordinate minus 2 plus 24u and minus 3 plus 10u, when these two are equal. So I can split those up into equation 1 and 2. So I have 1 that 7 plus 3t is minus 2 plus 24u, and 2 that 2t is equal to minus 3 plus 10u. I'll divide this one by 2 to get t is equal to minus 1.5 plus 5u. And then I'll substitute this into the t in expression 1. So I get 7 plus 3 times negative 1.5 plus 5u is equal to minus 2 plus 24u. So I get 7 minus 4.5 plus 15u is equal to minus 2 plus 24u. So 7 take 4.5 gives me 3.5. Adding 2 to that gives me 5.5. Is 24 take 15u is 9u. So 5.5 over 9 is equal to u, which is 0.61 recurring, or 11/18. And this is fine because it's between 0 and 1, so it definitely lies on H, so that's a good thing. So let's put this u into H to see what coordinates we get. So that means that x and y is equal, and this time I can take this expression for H, so minus 2 plus 24 times 11 over 18, and minus 3 plus 10 times 11 over 18. So I get 12 and 2/3 for my x component, and three and a ninth for my y component. And I can check this by putting this u into here for t, and then putting this t into the equation for g, and checking that I get exactly the same coordinates for g, because this is the point where they cross, so it's a point that they have in common. But I'll leave that as an exercise for you.